Hello. Another good example is this example on velocity time graph. The first example we looked at distance time graph and now velocity time graph. And now you need to remember what are the key points of a velocity time graph. First of all, the slope of the velocity time graph, which is the same as the gradient of a velocity time graph, which you definitely taking, for instance, from somewhere like this, you take that up, should be the same as change in velocity over time, and that is the same as acceleration. So that is acceleration. So we say that for an object that is moving on the first stretch of that graph, is moving at a steady acceleration or constant acceleration. And when we're asked to calculate the acceleration during the first 5 seconds, all we have to do is to take the gradient. So it's going to be the gradient, first section of the graph. If you take that, now the 150, so that's going to be 150 minus 0 over 5. So which is the same as 150 meters per second over 5 seconds, and that will be the same as 30 meters per second squared. That's how you do the first part of the question. The second part of the question says estimate the distance traveled during the first 30 seconds. The first 30 seconds is from here to here. Now, again, you need to recall the area under a velocity time graph. So, area under a velocity time graph equals to total distance covered. Okay, in that section. So, if we look at this now, if we decide to break this, we can break this into the first triangle there. Okay, they asked us to estimate, that would be another triangle, and so I can have 1, 2, 3. So I have 2 triangles and 1 rectangle. It's an estimation. Even though this is a curve, I'm just going to treat it like a triangle because I'm asked to estimate. It doesn't have to be accurate. So if you look at this, this is going to be half base times height. This is going to be length times breadth. And this is going to be another half base times height. Now, what do we get? The first part of the graph, if I say this is A, this is B, this is C. So my A will be half times 5 seconds times what? 150 meters per second. So if you look at that seconds, we cancel second out, and then you will be left with 5 times 75, because that's going to be 75. Work that out using our calculator. 5 75 times 5, 375 meters. That's A. And the B part will be again a half. The base here will be from here to here, and that is 5 to 30. That's going to be 25 seconds times 25 seconds times, and the height here will be from 150 to 300. That will be 150 meters per second. So if you do what we've done again, we're going to end up with 25 times 75, which is basically 5 times that. And that's going to be 1875 meters. And the C part, which is length times breadth, my length here will be from 5 to 30, that is 25 seconds. And from 0 to 150, that will be 150 meters per second. So I'm going to be left with 25 seconds times 150 meters per second. Second cancels second, so you are left with 25 times 150. 25 times 150 equals 3,750 meters. So we now need to add up everything, because what is the average, what is the distance traveled during the first 30 seconds? The total distance traveled will be the distance covered in all these regions, and that will be the addition of A plus B plus C. And if we do that, what do we get? Plus 1875 plus 375 equals 6,000 meters. And so the estimate here will be 6,000 meters. Now you can see that question carried 4 marks. Each of those efforts to actually determine the distance under the area will give you marks. What is the average velocity of the shuttle during the 30-second period shown on the graph? The average velocity of the shuttle during the 30-second period shown on the graph is, we're going to take the velocity stage by stage. We can take one section from A to B, and we can take the other from B to C. Okay? So, and we can average it out. Or we can find the total distance traveled over total time. We find the total distance traveled, so the average velocity will be 6,000 meters over 30 seconds. Okay, and that will give us 600 divided by 3, that will be 200 meters per second. That will give us the average velocity without sweating at all. And this is how we do a question like this when you come across it in the exam. Good luck.